Today's problem reads to us: Farmer John's pasture can be regarded as a large 2D grid of square cells. Picture a huge chessboard. Initially, the pasture is empty. FJ will add n cows to the pasture one by one. The ith cow will occupy a cell xi, yi that is distinct from the cells occupied by all other cows. A cow is said to be comfortable if it is horizontally or vertically adjacent to exactly three other cows. FJ is interested in counting the comfortable cows on his farm. For each I in the range 1 to n, output the total number of comfortable cows after the ith cow is added to the pasture. So essentially, in each iteration, we have to output the number of comfortable cows in the pasture or in the grid. So let's picture like what a comfortable cow actually looks like. Let's actually like, kind of visualize like what are the requirements for this code. So first, a cow is said to be comfortable if it is horizontally or vertically adjacent to exactly three other cows, meaning we can almost picture like a horizontally or vertically adjacent cow is like a neighbor, like a neighboring cow. So let's write neighbor, and excuse my handwriting, not great, but neighbor, and that's going to be equal to x plus or minus 1 or y plus or minus 1, meaning the x or y, the displacement is exactly 1, right? So that is what a neighbor is. Now it is comfy, so I'm going to write comfy if, and then neighbor, if the neighbor is exactly equal to 3. So if the number of neighbors is exactly equal to 3, right? Now, what else? Let's kind of like visualize this input over here. So they gave this sample input, sample output, and then some reasoning behind why the code gave this exact output. So zero, okay, so these are x, y coordinates. So I'm gonna just honestly, I'm just gonna graph like a x, y coordinate plane here, um, or graph. So x, y, right? And I'll graph three different scenarios. I'll graph this first scenario where it's 1 1 is comfortable. I'll graph the second scenario where 2 1 is comfortable. I'll also graph the third scenario where 2 1 and 2 2 are both comfortable. So for this first scenario, uh, I'll just put 1 2 and 1 2. All right. So first we have 0 1 over here. So that is a point on the graph. And then 1 0 is also a point on the graph. 1 1 is a point on the graph. And then when 1 2 is added, that's when there's one comfortable cow. What is a comfortable cow here? Well, we see that the only point here that is adjacent to exactly three other points and has three other neighbors is this point right here, which is 1 1. And that is why it says after the first four cows are added, the cow at 1 1 is comfortable. Okay, that makes sense. Now let's try the same thing but for the other input here. So we're gonna do the same thing, 1 2 1 2. So we're gonna have same points. Sorry about that. We're gonna have 0 1 1 0 1 1 1 2, and then 2 1. Now notice here how now after 2 1 is added, 1 1 isn't comfortable anymore, meaning we also have to check for each iteration for like the neighbors and check if the neighbors are like, let's say they were previously comfortable, if they're comfortable now or not, because now in this case you'd have to remove this from the comfortable list because it's not comfortable anymore. It has four neighbors. So let's kind of write that here. Each, so each, and then I'll just do like iteration. So each iteration you have to check not only like the actual point itself but also for the neighboring cows. So let's say like they were before they were comfortable, well now you have to check and like remove them from the comfortable array or whatever data structure we're going to use, right? So now there's still no comfortable cows, but after um, after 2 2 is added, after 2 2 is added, right? There's still no comfortable cows either. So now we're gonna have to extend this to 3 here. So 3. Now we plot 3 1, and automatically this cow right here becomes comfortable because we have one over here, one neighbor over here, one neighbor over here, and one neighbor over here. So it's comfortable. Now let's say we graph like the second 3 2, then this also becomes comfortable because now it has exactly 3 neighbors. So we can see we can graph this in a kind of like a coordinate plane here. Now let's translate this into arrays, right? So for example, here where it is where 1 1, where that cow is comfortable, what does the array look like? Well, we have the point 0 1, we have the point 1 0, we have the point 1 1, and we have the point 1 2, right? Now, in this case, we kind of see a pattern here, right? We see that there are exactly 3 other elements in this array that have either x plus or minus 1 compared to this, or y plus or minus 1 compared to this. So that's how we're going to kind of check in each iteration if that exists in this list or not, or in this array. Okay, so now that we have kind of like a general idea of what to do, let's translate this into code. Okay, so over here, I am going to be using Python today, but the concept should apply to Java, C, whatever program language you use, but today I will be using Python. First, we should start with, well, what's the input here? The first line contains a single integer n, so let's do n. It's going to be int input here, and that's just going to be like the number of like like the number of cows, right? So we're going to do for in range n. So basically here, this is where we'll be like iterating through every single cow, and we'll be putting our output over here. What else are we gonna need? Well, we're probably gonna need something to store the cows, right? So the cows are gonna be x, y coordinates, right? So x, y. So what does this look like? Well, this looks like actually a tuple or tuple, right? Now, if it's a tuple, then we can store it in sets. So we should do cows is equal to set, and here it's going to be a tuple, and also a set is also going to it's probably going to make the program run a little bit faster, and that is going to be useful. Now the problem with this is that we have to do it in on time complexity, meaning we can only do it in one for loop. We can't use any nested for loops. Okay, cows equals set. Then we should also probably create one like the comfy cows, right? So comfy cows is equal to set, right? Okay, and what else do we need? Well, we probably need a counter, like to count the number of comfortable cows at a given time so that we can actually output it, right? So we can set the counter equal to 0. So I'll just set that equal to C. Okay, now let's try to start actually coding. Okay, so in each line we're gonna have we're gonna have two numbers. We're gonna have the x and the y coordinate, right? So I'm just do s is equal to input dot split space, and then I'll have x y is equal to int s0 int s1. So we got the x and y already. Okay, now after each x and y, well, we obviously have to add that to the cows. Cows dot add, and then in fact I'll actually put like a tuple cow is equal to xy, and then cows dot add cow. Okay, now let's say like the point that we get, it is a comfortable cow. So we have to check for that. So if, and then we have to kind of like make a method almost to like check if a cow is comfortable. So let's do that. So in the top here, I'll define a method. I'll just be like check comfy, right? And then for the parameter, all we really need is a cow, right? Like I just need the cow, which is gonna be x and y coordinates, right? So I'll just do x y is equal to cow, so we can get the x and y coordinate from the cow. Okay. Now, if we have to check for neighbors, that's gonna be x plus or minus 1 or y plus or minus 1. So, what is a neighbor? Well, a neighbor is up, down, left, and right. So let's kind of name those like variables. So up is equal to, and then so up is going to be x y plus 1, down is going to be x y minus 1, left is going to be x minus 1 y, right is going to be x plus 1 y. All right. Now we don't actually know if up, down, left, and right actually exist in cows. So we have to check if they actually exist in cows. So if up in cows, then we almost have to like set it like a counter here too. And then if the counter is equal to 3, then it's comfortable, right? So I'll just set like comfy counter is equal to 0. Or let's do neighbors. Neighbors is equal to 0, right? So if up in cows, then neighbors plus equals 1. Then if down in cows, neighbors plus equals 1, you kind of get the gist here, right? So I'll just copy and paste it just for simplicity here. Right, up, down, left, right. Neighbors plus equals 1, right? And then if neighbors is equal to 3, then we're going to return true, like it is comfortable. Else, we're going to return false. Cool, now that we have that method, we're going to do if check comfy cow. So if it is true, right, then we can just, first we'll just add this to the comfy cows set. So if it's comfortable, then we're just going to add two comfy cows. Comfy cows are add cow. Okay, now that we have checked for the actual point, now we have to check for all of its neighbors, right? So we're probably gonna have to do this again. We're probably gonna have to do up, down, left, and right. So like for each cow, we have to get an up, down, left, or right, right? Okay, so now what do we do? Well, it looks like now the first thing we have to check for is if up, or like if the neighbor is actually a cow in the first place, like if it's in the grid. So let's do if up in cows. Well, what else we have to check for? We have to check if it's actually a lucky cow already or not. Because if it's already a lucky cow, then it's already been added to the counter. So we don't want to double add it to the counter. So, and up not in comfy cows, right? If not in comfy cows. And what else we have to check? Well, obviously we have to check if it's comfy, right? So, check comfort, check comfortable. And then up. So if all that is true, then if all that is true, well then we can add it to the counter of comfortable cows, and then we can also add it to the comfy cows set. So up, right? Okay. What else? Well, we also have to check. Let's say the cow's already comfortable, or it's already in comfy cows, but it's not comfortable anymore after this new addition. Well, let's try that. So we're also gonna do if up. Well, what do we do here? Well, if up is in comfy cows, right? And if it's already in comfy cows and if it's not in, or if it's not comfortable, so if comfy up, then we're gonna have to actually remove it from the number of comfy cows, right? So remove. Okay, well, this looks good so far. Now, don't we just repeat this for every other cow? Let's do that, that, that. Let me add some spacing here just to make the code a little bit more readable. And I'm going to fast forward here. Essentially just copy up, but then you replace it with down, left, right, do the same thing. So I'm going to fast forward here. Okay, well, it looks like now we have all of our if statements here that check for neighbors, and like we add them to a number of comfortable cows. So all that's really left is, well, we just have to print the counter, so print C. And looks good to me. So let's try it, and let's see if we did anything wrong. So to do this, I'll just go to terminal, and then, so let me zoom in real quick. So cd coding, cd random, python comfy cows.py. Let's run this. C minus equals, what did I do there? Oh, yeah, what? I don't know how that happened. Let's try that again. Right? Okay, and let's try it with the sample input output giving here. So 8 0 1 0 1 0 0 1 1 0 1 2 1 2 1 0 2 2 0 3 1 1 3 2 2. Okay, looks good here. So now all that's really left is submit it. Now submitting to USACO is really easy. You just have to log in. And then by the way, in the description I have like a link to like the actual problem page. So let's do that. Comfy cows. Submit it, see how it goes. And boom. Looks like we have indeed solved the problem. I will have a link in description to this code. If you have any questions on why this code works, like any problem solving part or anything in general, you can feel free to leave it in comments and I'll try my best to answer. Other than that, have a good day.